This is the beginning of 1.5 on page 119. This is 1.5a, and it has to do with functions and graphs. And we're going to look a little bit more detail as far as getting some information out of these functions and understanding different types of functions here. But the first thing we're going to do on page 119 is talk about increasing, decreasing, and constant functions. Let's go ahead and draw a function on here. Okay, so on a given interval, I'm reading at the bottom of page 119, if the graph of a function rises from left to right, it is said to be increasing. Okay, so when they say a given interval, they're saying that somewhere along the graph, you're going to grab a certain area of this graph. So let's say between these two black lines. That area between these two black lines is the interval that we're looking at. So in that interval, what is happening when we go from left to right? Our graph is increasing, okay, up to there. If our graph, and I'll do this with blue, goes from here, our interval goes from here to here, what is happening with that interval? Well, within this interval right here, we are decreasing. If, for example, we're looking at what happens between here and here, it may be that function is said to be constant. It's not going up or down. Okay, so that's what an interval is, and that is the increasing and decreasing. So, if you look in the middle of page 120, there's a little bit more information there. A function f is said to be increasing on an open interval I, if for all a and b in that interval a is less than b implies the function of a is less than the function of b. Okay, so let's look at explaining this. Let's look at the increasing part again. So we're going to look over here. Alright, as my x value goes, as I go from left to right, what happens to my x value? It goes from negative to less negative. My x value goes from smaller to larger. Well, what happens to the y value as I go this way? It gets bigger and bigger. So what it's saying is that as x gets larger, my y value also gets larger. So they're calling it f of a and f of b. So what they're saying is that if I have a point right here, and let's call that x, f of x, because the y value, the f of x, means what's going to happen to my y value, f of x, dependent on what my x value is. So I've got an x, f of x. And let's say I've got a point right here, and I'll do this in blue, and let's call it x1 f of x1, meaning it's still an x value, it's just a different one. In fact, let's do this. The book calls these numbers differently than f of x. The book calls them a f of a. Okay, so that's one point. That'll be this point right here. And we'll call, and I'll do it again in blue, this other point b f of b. Okay, and that'll be this point. What it's saying is that as long as a is less than b, which in this case it is, this one here is further to the left from the origin than the b value is, because the b value is to here. So if a is less than b, then that also means that my function of a is also less than my function of b, meaning that the distance from the y or the x-axis, my f of a, up, how far I went up here, will always be less than how far I went up here. Because a is smaller, f of a has to be smaller. B is larger, f of b has to be larger. So that's what they're doing as far as that little purple box on page 120 when they're talking about increasing. Decreasing, they're talking about the same thing, only they're going downhill instead. So in this case, a I'm clear over here, it's smaller, is smaller than maybe B over here. So therefore my y value for A is going to be larger than my y value for B. So, and then for a constant, they're both going to be equal. So if you look at the figure 2 and 3 on the bottom of page 120, it gives you your intervals and tells you what's going on there as far as the graph is concerned. Okay? So let's look at example 1 on the bottom of page 120. We've got this graph here, and what the instruction says is determine the intervals in which the function in the figure at left is increasing. Okay, so we're looking at where we are increasing from left to right. So what we've got here is we are increasing, let me get my little pointer here, from this point to this point here. We're increasing all along here until we get to 5. So we're increasing on our interval when from x equals 3 to x equals 5. Okay. So the function is increasing on the interval of 3, 5. Okay. So when we say the interval from 3, 5, we're saying we are increasing from 3 to 5. Notice I have the rounded there because we're not including 3 and we're not including 5 because those are the maximum and minimum points. Those are where nothing is happening. We're not increasing anymore. So we're not including 5. So we are increasing on the interval from 3 to 5. Now look at what happens with the range. We went from a -2 down here to a +2. So as we increased our x values from 3 to 5, our y values also increased, and that will always happen. Same thing over here. As this decreased from a number like maybe -3 and we got down here to -1, notice what happened to my y value. My y value at -3 went from, looks like about 6 down to about -2. So it decreased. So as my x increased, my y decreased there. Okay? So anyway, so 3, 5 would be my A. Now for the second part of that, it wants to know where it's decreasing. So we are decreasing from, let's see here, it looks like -infinity. So from here, because that will keep going this way. So we're decreasing there all the way down to -2. But are we decreasing anywhere else? Yeah, we're decreasing at this point here this way as well. So we're also decreasing from 5 to +infinity. And then it wants to know where we are being held constant. Well, we're being held constant from here to here. So you're going to say that we're being held constant from, looks like -1 to +3. And then we make a change there. Now notice these are all open intervals. Remember the closed intervals look like this, where it includes the number. These don't include the number. So these are all on open intervals. And if you look in the middle of page 120 in that purple, it does say it's said to be increasing, decreasing, or constant on an open interval. Okay? So if you look at page 121, relative maximum and minimum values, they give us a graph here. And let me take a picture of that graph. Okay, so notice that we've got a key word here when we're talking about relative and relative minimum, relative maximum. What that means relative to the graph that you see. We don't know. Down here somewhere, this graph may do some really weird things. It may, I mean, for all we know, it may just do something like this later on. So this would be the minimum, but we can't see that. So what we're doing is we're just looking at the part of the graph that we can see. So we're looking at the minimum points of the graph relative to what we see here. Okay, so like this one. This is a minimum relative to this area right here. And this is a minimum relative to this area here. And then here we've got a maximum relative to what we've got right here. Okay, so that's just what we're looking at. We're looking at the interval and then going from there. So on the bottom of page 121, suppose that f of a function for which f of c exists for some c in the domain f. Okay, so this right here, the that point would be c1 f of c1, right? And this point here would be c2 f of c2, and etc. So it says f of c is a relative maximum. So we're going to look at this point right here. If there exists an open interval I containing c such that the function of c is greater than the function of x for all x in the interval where x is not c. Okay? So what we're doing here is looking for a y value, an f of c value that's bigger than any of the other y values here. And they're calling them f of x values. Okay, so that would be a relative maximum. Relative minimum would be that in our interval, so let's say that we're looking at an interval such as this area right here to right here. Our relative minimum is going to be there exists a point containing c such that this number, my y value there, how far it goes up, is going to be less than any of these y values here, here, or over here, okay, based on my interval I that I've got.